Okay, so I'm going to eventually show how to do this problem 2 different ways. When you look at these problems, always notice the first thing I'm observing. How many terms? It's 1 term. So when I take reciprocals, they're going to stay within that 1 term, easy peasy. Any fractions already? Oh, yes, there are. So when I take reciprocals, I won't be creating fractions. They're already there. So for many people, it's easier to remove the negative exponents first by taking the reciprocal. So what I want you to do, try this problem. Try removing all those negative exponents by flipping, and see if you can simplify that. So pause the video, give it a try, and when you think you have the right answer, turn it back on. I'm going to go ahead and go over this. Hopefully you paused it. You really do get more out of this if, when I give you time to try a problem, that you go ahead and try it. So this is all 1 term. This is the denominator of this numerator. So when you take reciprocals, you have to flip numerators to denominators of that same term. So since this is all 1 term, this is very easy. The 7 to the negative third just comes down as 7 to the third in the bottom. And by the way, notice what I did first? I drew the fraction bar first. So I could have everything placed in the numerator and denominator as it belongs. The x to the negative 4th, that says take the reciprocal. It goes to the denominator of that 1 term. The y to the 2nd doesn't say take the reciprocal. I'm leaving it in the numerator. All right. Now, the 7 to the negative 2nd, it's in the denominator. When I flip that, that comes up to the numerator as 7 squared. X to the negative 1st, when I flip that, that comes up as x to the 1st. And then the y to the 8th isn't going anywhere. So I still have a fraction, but I don't have any negative exponents, which makes it a lot easier to deal with. Remember, the exponential rules work for any base. They work for x's and y's as well as numbers. So I can think 2 of these 7s cancel with 2 of those, leaving me 1 7 in the bottom. Then I look at the y's. 2 of these y's cancel with 2 of those y's, leaving me with y to the 6th in the bottom. And then 1 of these x's cancels with 1 of those x's, leaving me x cubed in the bottom. And you can't leave it like that. Remember, the coefficient in the numerator was 1. So the 1 is remaining in the numerator. And you can leave it like that. It just disturbs me because we're so used to writing variables in alphabetical order. You'll see me giving the answer like this. But multiplication is commutative, so these are the same. All right. That's the way it would run if you remove the negative exponents first. Now, if you say, I don't do that. I want to use my exponential rules first. And there will be times where certain problems, especially when we get to fractional exponents, you're going to want to be able to do it this way too. So the way you do it without removing the negative exponents first is you sort of peel off the factors with the same base. Okay, so I'm going to work with the same base, and I'm going to realize I'm just going to use the division rule for dividing like bases. When you divide the same base, you keep the base the same, you subtract the top exponent minus the bottom exponent. Watch for double negatives. Top exponent minus the bottom exponent. Times, dividing the same base, keep the base the same, subtract the exponents, top exponent minus the bottom exponent. We get a double negative that way. One of the most common mistakes when doing it this way is overlooking the double negative. Times, do this for the y's, dividing the same base, subtract the top exponent minus the bottom exponent. And so this is going to be 7. Now I'm not going to write this down, I'm going to do it in my head. The double negative is plus 2. So negative 3 plus 2 is 7 to the negative 1st. Negative 4 plus 1 is x to the negative 3rd. And y to the negative second. And then you flip, every factor goes to the basement, and you realize you need to keep the 1 in the numerator to hold the place, and you get the same answer. So, I don't care which way you do it. I think it's a little bit easier this way to deal with, but when we get to fractional exponents, there are times when you're going to need to be able to just subtract the exponents, top minus the bottom, when you're dividing like bases. Okay, so let's try one more. So you should try this problem. I've got some hints here, but pause the video, try the problem. When you think you have the right answer, turn the video back on. So I'm going to go ahead and start this. How many terms? This is all one term, which means when I flip, it's going to be easier, but you've got to watch order of operations. You cannot start flipping and canceling anything, because this really isn't an x to the negative second here because of this negative 3 power. You have to think, I need to find the answer. Once I have that answer, then I can divide. So your first order of business, you can just ignore the denominator for a while. First order of business is just to deal with that negative 3 exponent here. And that's a fairly simple problem. You have factors, so you can distribute the exponent to each factor. Don't rush. And that's kind of the big thing with negative exponents. Don't rush. Don't try to do too much in your head. 2 raised to the negative third, just write it down as 2 to the negative third. You'll deal with the negative exponent later, because that is not negative 8. X to the negative second times x to the negative third, power to a power you multiply, that is a negative times a negative, so that's x to the positive 6. Y to the 5th raised again to the negative third, that's power to a power. You multiply exponents, that's y to the negative 15th. Over x to the negative 8th. Oops. Guess what? That's a typo. Doggone it. So, it was supposed to have been a y. Yeah, I guess I'll leave it as an x since you guys probably all worked it that way. X to the negative 10th. I'll just leave it that way. Wasn't my intention. Okay, so the filled-in notes probably has that changed to a y, so it's a slightly different problem. The next thing you could do is in the denominator, since I have my little, it's not a typo, it's a hando. They're the same base, you're multiplying the same base, so you add the exponents. So that's x to the negative 18th. And now, you could subtract the exponents here, top minus the bottom, and then flip, or you could flip first. So I'll do it both ways. I'll flip first. Most students like that better. So when you flip first, I'm going to go all the way up here for that. Draw your fraction bar. The 2 to the negative third comes down. The x to the 6th stays where it is. The y to the negative 15th comes down as y to the 15th. The x to the 18th comes up. And so this is x to the 24th over 8y to the 15th. And notice, 2 to the negative third, it was not negative 8. There's an invisible 1 here. It was 1/8. Okay. Now, if you decide I'm going to keep simplifying with the exponential rules, there's only one thing left. You know, if you're back at this point, you have the same base, which means you can simplify by using that exponential rule. This would be 2 to the negative third. Dividing the same base, you subtract exponents, keep the base the same, so that's x to the 6th minus a negative 18. Watch that double negative. Y to the negative 15th. And so this is 2 to the negative third. That's really 6 plus 18, so that's x to the 24th, y to the negative 15th. And then you say, all right, I got everything as simple as I can, except that I haven't removed the negative exponents. So draw your fraction bar. The 2 cubed goes down. The x to the 24th stays up. The y to the 15th goes down. And I'm kind of out of room, so I'm going to just draw a little arrow or a little equals. 2 to the 3rd is 8. You get the exact same answer.